The way I'm going to approach this, I know you can put this over 1 and cross multiply, but I'm going to approach it with the idea that I'm multiplying both sides by the common denominator. Okay, x plus 1 is the common denominator, so if I multiply this side by x plus 1 and that side by x plus 1, what it'll do on this side is it'll reduce, the denominator here, so I'm left with a 2x minus 2. Over on the other side, I've got a 4 times x plus 1. Some of you might do that in that single step, and that's okay. Just keep track of what you're doing. Stay organized. Okay, you distribute the 4 now. You get a 4x plus 4 equals 2x minus 2. I'd move the x's to one side, the numbers to the other side. If I subtract 2x from both sides, I get a 2x. And if I subtract the 4 from both sides, I get a negative 6. Divide both sides by 2, and I get x equals negative 3. Okay, that is one of our solutions over there. This one's the same basic principle, except for over here, I could cross multiply, but here I can't, at least the way it's set up right now. I could combine these together and then cross multiply. That's always an option. But I think it might be just as easy just to go through the process of identifying a common denominator to be 3x and x plus 6. Okay, the 3 is actually accounted for in both of these, but you have to include a separate x than this x. So 3x times x plus 6. That's our common denominator. We're distributing it to each of these 3 different terms. Now it gets a little bit, crowded here. But 3x times x plus 6, that gets at least you set up to reduce your fractions so that you can see what you have left. Now the 3x here cancels with this 3x, leaving me with just this x plus 6 times 2. So if I distribute, I get 2x plus 12, and that's distributing this to here. The only thing that reduces here are these 3's, leaving me with a 2x that I need to distribute through the x plus 6. So that gives me a 2x squared plus 6x. Okay, and all that's done here, it's equal to, I'm canceling the x plus 6's here, leaving me with 8 times 3x, which is 24x. Now, as you normally would when you have an x squared term and x terms and all that kind of stuff, it's good to get it all over to one side. So I'm going to subtract the 24x from both sides, and you'll see that I've got some like terms here. That's a 24x. So I've got 2x. Oh, shame on me. I distributed it 2. This should be a 12x. So go back and change that. Sorry about that. We caught it though before the end. 2x and 12x gives me 14x minus 24x. That leaves me with a negative 10x. So this is gone. We're equal to 0. I'm going to move up where I've got a little more space here. I've got a 2x squared minus 10x. Again, the 10 came from this 2, that 12, this 2x, that 12x, which is 14x, minus 24 when I brought it over. And then the last thing here is this minus or plus 12. Now that's equal to 0. I would suggest taking out a 2 here because they're all even. It's much easier to factor this if I have it like this, plus 6. Well, if you're factoring something that adds together to get 6, but multiplies together to get a positive 6, but adds to get negative 5, that has to be 2 negative numbers. It's a negative 2 and a negative 3. They'll multiply to get your positive 6 and add together to get your negative 5. Now the 2's still out here, and it's still equal to 0. But instead of 3 different answers, you're only given 2, because if you set that equal to 0, you add 3 to both sides. One of your answers is 3. You set that equal to 0, you add 2 to both sides, you get a 2. But if you set this equal to 0, it's basically a contradiction. Okay, 2 is not equal to 0, so you wouldn't include that as a solution. One thing I would just make sure you take a look at, you've got solutions where x is in the denominator of a fraction. You got to just at least take a look to see if you plug those in, does that give you 0 in your denominator? And it doesn't in either of these cases. So far, those are the solutions.